Hello everyone! Welcome to another episode of Science Lecture video series with Sir Geronimo. Let's get started. Today we are going to start learning about chemistry. So we are now going to focus on the diversity of materials in the environment. So in this video, we are going to start learning about properties of matter. This will be our first lesson in this unit. So what are the lesson objectives for this video? First, we are going to define what is matter in its composition. After that, we are going to describe the different properties of matter. Now, before we proceed to the properties of matter, it is very important for us to have a short review about what chemistry is all about. So just like biology, physics, and earth science, chemistry is a science that deals with the study of matter. We focus more on its composition, properties, classification, and the changes that the matter undergoes, particularly the chemical reactions. Now, whenever we study chemistry, some of you, if not all, will be having a face like this. But I hope that at the end of this lecture video series about chemistry, you will be enlightened to explore more about chemistry. So let us start with our lesson. Let us define first what matter is all about, because chemistry is the study of matter. But what is matter? Matter is said to be anything that occupies space and has mass. So meaning to say, as long as this particular thing occupies space, it has volume and has mass, it is said to be a form of matter. Some examples includes your cell phones, your laptop, your house, your food that you eat, and everything that occupies space and has mass or takes up mass. And matter exists in various states. And I'm sure that you are all familiar in these states of matter. So we have the Bose-Einstein condensates, solids, liquids, gases, and plasmas. So let us take water as an example. The solid state of water is ice. So when we heat water, it will melt to become a liquid form, water. But when we heat water to reach its boiling point, it will become a steam. So the gaseous state of water is steam. The liquid state of water is water. And the solid state of water is solid. So water is said to be a form of matter because it is not just being stated for having different forms of matter or different states of matter, but it's also capable of occupying a space. When we fill our glass with water, so it occupies space and it has mass. So whenever we measure water, it has mass. Therefore, water is an example of matter. Now, what is matter made up of? What is the composition of matter? What is the building block of matter? So it is said to be that atoms are the building blocks of matter, and they are extremely small. No, we cannot see atoms using our naked eyes. No? And this picture right here is a representation of an atom. So when you reach Science 8 Chemistry, you will learn about the different atomic models, and this is one of the atomic models. So we are not going to talk about the atomic models in this video. I just showed you a picture representing an atom. So just like building a house, of course, you need raw materials in order to build your house, no? So same with matter, the building blocks of matter are atoms. And all matter is composed of atoms, regardless of what state that particular matter is undergoing, or whatever the property or composition of that matter is, the atoms are its major building blocks. And atoms cannot be broken down into smaller pieces by any chemical means. So whenever we divide or we break down atoms, it will still be atoms. Now, let us talk about the properties of matter. So we are now going to be familiarized with the different properties of matter, and when does understanding the properties of matter become beneficial? When are we going to use our knowledge in understanding the properties of matter? So these two key questions will be answered after this video. Now, let us talk about the properties. So what are properties? In general term, we are defining the word properties as observable and measurable characteristics used to describe matter. So these are any characteristics that we use to describe a particular form of matter. Some examples include color, shape, texture, size, etc. Now, there are two classifications of matter, or there are two classifications of properties. First, we have physical properties, and we also have chemical properties. Now, just like in this GIF, we can say that there are some characteristics of water that we are using to describe it. No? So, whenever we melt ice, it turns into liquid state water. So, as we observe this particular phenomenon with ice, so we are actually gathering information that we use to describe what happens. And that is what we are going to talk about properties. No? Now let us talk about the physical properties of matter. From the word physical, we say that these are properties that can be observed or measured without changing the composition of it. Okay, so we are gathering information, we are looking at the physical appearance of that particular form of matter without changing its structure, its composition, its constitution. No? So this includes the following: luster, malleability, ductility, conductivity, hardness, brittleness, melting point, boiling point, and freezing point. Now, when we talk about the physical properties of matter, we are looking at the characteristics that we see, characteristics that we hear, feel, smell, and measure. So without changing the composition of it, we are actually gathering information about it. That we are using those particular information to describe that matter. So let us have the first physical property. The first physical property that we are going to talk about is luster. Luster is the measure of how shiny a substance is. So it's either not shiny or shiny. When we say that a particular substance is shiny, it is said to be lustrous. But if it is not shiny, we say that it is dull, just like this rock. No? So whenever an object is not shiny, it is dull. But if it is shiny, it is lustrous. And the measure of how shiny a substance is what we call luster. Okay? Next, malleability. Malleability is the ability of a substance to be beaten into very thin sheets. Some examples includes this ring, no? Ring, aluminum foil. So what happens? So whenever a particular substance or a material is hammered, no, and it does not break down, therefore it becomes, or it is being beaten into very thin sheets. Therefore, that particular substance or material is said to be malleable. Meaning to say, it is capable of being beaten into very thin sheets. So gold is the most malleable metal because from a chunk of gold, when hammered into very thin sheets, it becomes coin, no, plates, if there is, rings, or jewelries. So therefore, gold is malleable and it has the ability to be beaten into very thin sheets. And also, just like this aluminum foil. So it is beaten into very thin sheets. Next, let us talk about ductility. Ductility is the ability of a substance to be stretched into very thin wires. So the difference between ductility and malleability is that malleability is just the capability or the ability of the substance to be beaten into very thin sheets. But if the substance is capable of being stretched into very thin wires, it is said to be ductile or ductile. So again, malleability, thin sheets. Ductility, thin wires. Some examples includes copper wires, no? So from a copper, it is capable of being stretched into very thin wires. This chains that is made up of iron is capable of being stretched into very thin wires. As well as this spring, no? It is being stretched into very thin wires. And that is what we call ductility, or its ability to be stretched into very thin wires. Next, conductivity. Conductivity is a physical property that is said to be having an ability of a substance to allow the flow of energy or electricity. Meaning to say, it is capable of flowing heat or electricity. When a material or a substance is capable of flowing energy or electricity, it is said to be a conductor. But if it is a substance that does not allow the flow of energy or electricity, it is said to be an insulator. Just like in this picture. So we have plastics, paper, wood, no? That's why whenever someone is being electrified due to an electrical source, we don't use metals, no, to drag the body away from the electrical source. Instead, we are looking for a wood so that whenever we drag the body from the electrical source, we will not be able to be electrified also. Since woods are insulators, it does not allow the flow of electricity or any form of energy. Same goes with when drinking a hot coffee, no? Before drinking that hot coffee, we use utensils, particularly spoon, so that the spoon, which is a conductor, absorbs the heat coming from the coffee. So whenever we sip our coffee, there will be no heat at all, or the temperature will be lowered. Next, hardness. Hardness is the measure of how easily a substance can be scratched. No? How easily a substance can be scratched. So if a substance is very hard, it is said to be inscratchable, or it cannot be scratched. No? So some examples includes this chunk of wood or block of wood and rock, no? Or stones. And if the substance or if the material is capable of being scratched so easily, it is said to be soft. No, just like towels, cotton, no. So these are another property. This is another physical property of matter, hardness. Another property of matter is brittleness. So this is the ability to break easily. So whenever a particular material is brittle, therefore it is capable of being broken down easily. Some examples of brittle materials are sulfur, coal, and light bulb. So if it is not capable of being broken down very easily, it is not brittle. But if it is capable of being broken down easily, it is brittle. So that ability is what we call brittleness. Another physical property is melting point and freezing point. So let us differentiate the two. Melting point is the temperature at which the temperature of the solid melts to become liquid. So sorry for the typographical error. So the solid melts to become liquid. So when we say melting point, that is the exact temperature when the solid melts to become liquid. No? And then when we say freezing point, it is the opposite of the melting point in a way that it turns the liquid into solid. Okay? So those two are two different terms. So when we say melting point, the solid melts to become liquid. So there's a particular temperature for that particular matter to become liquid. And when we say freezing point, it is a temperature at which the liquid turns into a solid. Next. So some examples of melting point is this. So if the temperature of this glass of ice is negative 15 degrees Celsius, so the ice does not melt pa, no? But when we lower or when we increase the temperature, let's say for example, it becomes 0 degrees Celsius or 32 degrees Fahrenheit, the ice begins to melt because water has a melting point of 0 degrees Celsius. So when the temperature of water is 0 degrees, when the state of that water is in the form of ice, the ice that is made up of water becomes to melt and it becomes water. Okay, but if we lower the temperature, let's say for example, it becomes negative 15 or negative 25 degrees Celsius, it will solidify to become ice. And then when we talk about freezing point, that is the temperature at which the substance changes from liquid to solid. So, unlike melting point, this time, the liquid will become solid. And we are going to measure its freezing point, that particular temperature. Next, boiling point. When we say boiling point, it is the temperature at which the vapor pressure of a liquid is equal to the pressure of the gas above it. And it is the temperature at which the liquid starts to boil to become gas. No? So, melting point from solid to liquid, no? The temperature at which the solid becomes liquid. Freezing point, the temperature at which the liquid becomes solid. And boiling point, the temperature at which the liquid becomes gas. Now, let us have the chemical properties of water. When we say chemical properties of water, these are properties that can be observed only when the identity changes. So unlike physical properties wherein we are not considering the composition of it, the composition of matter, in observing chemical properties, we are looking at its characteristics when the identity changes. So if it changes, it is chemical. Take note, if the matter changes its composition or its identity, it is said to be chemical. Some example of chemical properties are toxicity, oxidation states, heat of combustion, chemical stability, flammability. So if this particular substance is flammable, that is a chemical property of it. An example is alcohol. So alcohol is a flammable material. So whenever we expose alcohol to heat, it will produce fire. So it is flammable. So that is a chemical property. Reactivity, possible chemical bonds, enthalpy or enthalpy of formation. So we are just going to focus on some major chemical properties of matter. So let us start with reactive to oxygen. So I'm sure that all of us are aware that whenever we expose a metal or iron with water, no, there will be rust. So that process, the process behind that is what we call oxidation process. It is a chemical process of combining a substance with oxygen. So since water contains oxygen molecules, whenever it is exposed with iron, it will undergo a chemical reaction to produce iron oxide, also known as rust. Okay, so whenever an iron is exposed to oxygen, there will be the yielding of iron oxide or rust. Another chemical property is reactive to water. Just like in this picture, whenever we have lithium exposed to water, it will have a chemical reaction. You know, just like also sodium. When we have a sodium, place it in the water, it will explode actually. Okay, so that is another chemical property, reactive to water. And then another chemical property is this, reactive to air and water. Now, did you know that the Statue of Liberty is made up of shiny orange-brown copper? But the metal's interaction with carbon dioxide and water has formed a new substance. So, copper carbonate. Instead of copper alone, it became copper carbonate because of carbon dioxide that is found in the air and water. And because of that, it made this landmark lady green over time. So originally, it is colored orange-brown, or the color of the copper. But since it is being exposed with water and air that contains carbon dioxide over time, it becomes, or it has undergone a particular chemical reaction to become copper carbonate, which is the color changes. So therefore, we can see the Statue of Liberty now as green or dark green or blue-green in color. Now, what are again the properties of matter? So there are two properties of matter, physical properties and chemical properties. These are the two categories. So within the physical properties, we talk about luster, malleability, ductility, conductivity, hardness, brittleness, melting point, boiling point, and freezing point. And for chemical property, we talk about reactive to oxygen, reactive to water, and reactive to air. So when does the understanding of these properties of matter become beneficial to us? First, it becomes beneficial whenever we choose the kind of material whenever we buy from a store, from a market, no? We look at its properties. That's the main importance of looking at its properties. We are capable of observing and measuring its capabilities or characteristics, no? So whenever we consume something, no, any material around us, we are looking first at its properties to ensure the safety of that particular material. Okay? So that's all for our lesson for today for this lecture video series. I hope that you learned something about our lesson for today. Thank you for listening and see you on the next lesson.